Okay, so the part we're gonna to use for this tutorial, it's the main plane of a front wing of a Formula car, and it's a assembly composed by different components. They are the side wing rib, a tube, another rib for the wing, aluminum part for structural support. This is the lower part of the main plane. I have another side rib, the top part of the main plane, and the mirrored components. Okay, so first thing we need to do is make sure that our wing, our part is correctly constrained. I mean, these constraints, they doesn't mean that there is a physical relationship between the parts, but they simply let each part be in their correct position. So this is extremely important in order to create a sheet model. So that's what we're gonna do. Now we have this PRT file, but what we're gonna do is that we're gonna create a sheet model of this file. It's basically to convert this geometric solid part file into a sheet body. Is a tube with elements represented by in 2 dimensions. So how do we do this? The first step is to go in File and create a simulation. So it's inside the finite element method file that we're gonna to create the sheet model. Okay, so we select NX Nastran, and what we're gonna do firstly is FEM, and it's not a simulation. It's the setup for the further simulation. Our folder we're gonna select. We want this in the tutorial folder. Okay. So what's gonna happen is that we are gonna to create an idealized part. Basically, the program creates a clone copy of the original part file, and so then we can just work in this idealized part. Is not our original part. If you don't want to change the characteristics of our original file, we can select this option, create idealized part, and that's what we want to do. And the name, it's gonna be fm1 underline I dot prt. So it's still a part file, but because of this underline I here, we can assume that's the idealized part. Bodies to use, all visible bodies. This is all good. Solver is an X Nastran, that's okay. Okay, so now we are inside a FEM file, you see. So if I go on Control Tab, I was on my part file previously inside the modeling application. That's why we have this PRT, and we can do all kinds of modeling with this body. And now we went to inside a FEM file, and this file, it's, if you see here in the tree of the simulation navigator, you can see that this FEM file is taking as input the idealized part file, and we need to change this part file to a sheet body file. So that's what we're gonna do now. So we select. So it's basically saying that before we can modify this geometry, we must promote this part, and that's what we're gonna do. So now Control Tab again, just to show, we have our finite element method file, we have our original part file, and now we are inside the idealized part file. So this is our part file. We see that we don't have the components here, it's just a copy from the assembly, the original assembly. And what I need to do here is that in order to create a sheet body based on this part, we need promote this file. So how we do this? You go in promote, and then we select all the bodies that we want to promote, and then apply, and OK. So now we can create mid-surface. We can utilize this function that's basically a sheet function that allows us to create a sheet part file based on this geometry. So here we can see how the files is relating with each other in the assembly navigator. So we go here, we have our idealized part, and then here we have the roots. That's this idealized part file is taken as a reference. Okay, so that's good. And here is the part navigator, and it shows us the bodies that we just promoted to be able to work with. Okay, so we are here now, and what we want to do is that we want to create 2D sheet body based on this wing. So this wing is gonna be not a solid body like you can see here. There is a thickness, and we don't want any thickness. We want a thickness of 0 because that's necessary in order to create the mesh afterwards, to represent a composite material. And okay, so what we do now is create mid-surface by pairs, and we can start. So basically what we need to do here is we first select the body. So you're going to select this this top part of the main plane, and our strategy to create this solid body is going to be manual, and we must now select the faces that we're gonna use to create. Oh, sorry, here first face, the top is this one, the second face, the bottom, this one, and then apply. Okay, so now what we have here, we have a sheet body based on this function. And just to show you guys how to see that we do have a sheet body, you can see this line in the middle. That's what represents the sheet body that's in between these two faces that we selected. So it's pretty straightforward, it's easy to understand. So if, for example, if I go here and hide, I can see that I have this blue sheet body, and that's what we want to be our solid or our part file model, to be able to mesh it properly. Okay, so and pretty much what we're gonna do now is the same for all components. So important to notice that when I selected the top main plane, the software selected just the face. It didn't select the body, complete body. So now I need to do the same again for this part of the body that was not selected previously. So that's no problem. Go here, this body, this face, go inside that face. Oh, it's for the second body, this face, apply. Okay, so now we have our second mid surface body, and we do the same for all the rest. So it can get actually pretty quick to do it. When this body, this face, and that one, apply. Same here, and this body, this face, the first, and this second face, apply. Okay, now we're gonna select for, I'm gonna actually hide this. I can choose this one, yes. So this body and this face, this inner face, apply. So now we have our mid-surface body for the lower part of the main plane. Now I'm gonna hide this just to make it easier to work. Can hide this one. Okay, good. So let's do for these ones now. Mid-surface by pairs. That's one strategy to make it. I mean, all you need is a 2D body. Like if your part file is already a 2D model, is already a 2D part, so we don't need to go and do it inside the FEM. We can export directly from your CAD. So we want this body, this face, this one, apply. Same for this body. Select this face, select that one, and apply. That's okay. And now what we're gonna do is that we're gonna go in view, show and hide, and I want to hide all solid bodies. That's what I have, and I want to show all the sheet bodies. So that's what we have. Now we have a model that that's a 2D. There is no thickness. It's a 2D part file, and this is necessary. This is important to mesh inside the FEA later on, because if this is a solid, you cannot mesh a solid as a composite material. So, but that's not the end, because as you perform this kind of thing, you might have to fix your model because it's not representing exactly the original part file, because all these are mid-surface bodies, and they are not the exact part file, even though it's very similar. So if you remember, we had for the top main plane, we have select face, we have this face and this face, and they are also a different part, so they are not connected. So all this wing, it's not connected, it's in position, but there is no relationships between all these elements. Oh, I also forgot to do it for the tube. Our tube is also a composite, is also from composite materials, so we need to do it for the tube as well. Okay, so what we're gonna do to fix our model is that we're gonna use I think this is also important to explain before proceed with what I need to fix, is that if you go in application, you can select many kinds of applications to work with. So at the moment we are in the pre-post application, so that's why we have this set of tools available. But if I go, so yeah, it's the same, as you can see, same tools. So this is pre-post, and But if you want maybe more tools to work with your model before go to the FEA, you go in modeling, and now you have more set of tools to manage this. So what we want to do is that we want to sew the bodies that should be connected with each other. So for example, to fix this top main plane, we need to sew this edge and make these two bodies a single body. Otherwise you're going to apply the load on this square and it's not going to transfer to the rest of the part, of course. So how you do this, go in here, it's a sheet function, go and recently use it, and these are the most common ones that use delete body, extend sheet, and sew or trim sheet if necessary. You can do all kinds of operations. So we're gonna sew this body, so select sheet body. So it's important to notice that this function is just for sheet bodies, not for solid, as you can see. I can also have for solid, actually, that was my bad, but we want for sheet. So you can select our body, this one and this one. The tolerance, wow, 0.1 millimeters, 0.01, that should be still enough because it's the same. So now that's what we have. We have a physical. If I go here, my selection filter, and I can select sheet body, and now is everything red. So that means there's a single body. That this was created by this function here. Okay. So let's create our tube sheet model. And to create the sheet model of the tube that goes inside the wing, we must first visualize our tube. So we go in view, show, and what we want to show is the tube, and let's also select this aluminum ribs. Okay, so that's what we are seeing at the moment. And so let's proceed with creating the sheet model for the tube. So again, go in mid surface by pairs, then it select the inside face and the outer side face. So what I'm gonna do first is that I'm gonna hide this, so then I'm able to access the interior. So mid surface by pairs, this is our body, the first face, the second face, and apply. You can see that's there, the line representing the mid surface. And what else? Yeah, that's it. Now we can hide the tube, the original tube, and now we need to make another fix on this model, and basically because we created the mid surface of the rib, now we have this gap between the tube and the rib, and that's not representing the reality. So it's very easy to fix it. We go in go here, you can select an application for sheets, not finding here, so let's remember that we are in the pre-post. I close the window and I open again, and we are in the pre-post application, so that's why I'm not able to see the tools. So we go here in modeling, and now we are able to find within the surface this tool, that's extend sheet. So click here, select the edge, that's the edge we want, select face, this face. You see that the extension was created. So apply, that's good. We need to do the same for the other side. So let's find our rib, show. I want to show this sheet body. Okay, there it is. So same again. Let's go in home, application, and what we want is we can go in surface and extend sheet. So select the edge, select the face, apply. Okay. So because of this strategy that we are using to create our sheet model, we ended up with some gaps. Like if you look really close here, you have a gap between the side sheet and the lower part of the main plane, but that's not a big problem, because what we're gonna do is that we're gonna to glue this part with this lower part. So we're gonna glue all these ribs and the tube, and then the model is gonna be constrained. Of course, if the gap was too big, we would have to use some of the tools like extend or trim sheets and sew, or maybe trim a part of a body, but it's not enough, it's not necessary, it's close enough to accept a glue in between, so that would be okay. Okay, so yeah, our model now so now we have a 2D model. It's a sheet body with all these blue components, and we're also missing the top part. So let's go in view, show and hide, sheet bodies. I want all of them. Okay, and the sheet bodies, and also this 3D aluminum part that is not 2D geometry. So, but we can model this together with the 2D geometry, there is no problem. So this is the first part, getting the part ready, and now we are ready to create the mesh. Okay, so now that we are ready to move on to FEM to start our modeling and our meshing, I just want to remind in which environment we are currently in. So we have 3 files open. We have this one, that's our analysis file, finite element method analysis file, and you can see the symbol here is a pre-post symbol. And then from this file we created an idealized part, that's this file, and inside this idealized part we created our sheet body model based on this one, that's the original part file. So it's 3 files: the original file, the mesh, let's say, file, and the idealized part file. So now we are gonna to jump into the FEM file, and here is where we can make and create our mesh and define our materials and all the properties that we need to run our simulation.